in our generally accepted definition of this world. But everybody sees the world a little bit differently, which is a benefit. But it's only a benefit if it's communicated to each other. If there is no bias, no label that prevents us from honestly, open-mindedly listening to one another.
They saw. This testimony goes to the heart of the relationship between the outside world, the brain, and what we call reality. To understand it, we need to look more deeply into the visual system. This is the thalamus, one of the brain's major junctions. Most sensory information connects through here on its way to the outer surface of the brain, the thalamus. So data collected from the eyes stops here before going to the visual cortex. Now, you'd expect a heavy flow of information from the thalamus to the visual cortex, and there is. But there's 6 times as much traffic flowing in the opposite direction, and that dwarfs the amount coming in from the eyes.
The thalamus is a major junction point, an organelle in the brain. And its major function is to act as a warehouse for visual information. So the eyes gather light and turn it into electrochemical impulses, and it's sent to the thalamus. And the thalamus sends it on to the brain, the visual cortex. But the visual cortex sends 6 times as much data as the thalamus receives from the eyes to the thalamus. So there's a two-way feedback.
The visual cortex sends its internal expectations to the thalamus, and the thalamus compares those to what's coming in through the eyes. The difference between the two is what the thalamus sends back, so the cortex can update its model. Thanks to the internal model, the world out there remains stable, even when I'm moving. But it plays the trick of making us feel as though we've seen it all. As another famous experiment shows. In the 1960s, the Russian psychologist Paul Yarvis used this painting, called The Unexpected Visitor, in an experiment. He devised a way to track the eye movements of volunteers who were seeing it for the first time. Hi, Jennifer.
Hello.
I'm going to ask you to put these glasses on. We're going to rerun what he did. My volunteers have a few seconds to take in the image. Nina, look at this painting. I want you to gather what's going on in the scene. We can watch in real time exactly where each person's eyes go. Tell me what you think is going on in this painting.
I think the man in the brown is the unexpected visitor.
One brief look is enough for the brain to model the picture. But just how detailed is that model? How many children are there?
There are two.
Okay, so go ahead and look back at the painting and ask that question again.
Oh, quite different.
How many children are there?
I consider it three.
Everyone who'd seen the painting thought they knew what was in it. But my specific questions highlighted blanks that the brain had never filled in because the details weren't needed. How many paintings are on the wall in their house?
Maybe two or three.
Okay, go ahead and look back at the painting and answer that
Oh, God,
question.
there's a million. Yeah, map, and then another, and then there's 7 on the other wall, and then one small one in the map. Okay, there's a ton.
This is not a failure of the brain. It doesn't try to produce a perfect simulation of the world. The internal model is a hastily drawn approximation, and more details are added on a need-to-know basis. When you looked at the painting the first time, you saw sort of a rough draft of what was going on. And when I asked you specific questions, you had to go and answer those by looking, by turning your attention onto specific parts of the painting, and only then did you actually see it. So placing your eyes on an object is no guarantee of seeing it. But there's something else we're unaware of happening every time we look at any picture or person or thing. Anytime we look at all,
Can you see how our stories are converging on this point? Now. Let me share with you a couple things. You can do searches and find out why you can miss things happening right in front of you. This article or this one, missing the gorilla. Why we don't see what's right in front of our eyes. We have a couple minutes, so now the monkey business illusion, 2010. But this has been a recurring experiment in modern behavioral psychology for a long time. I took part in an experiment like this in Jomon-jida.
The monkey business illusion. Count how many times the players wearing white pass the ball. The correct answer is 16 passes. Did you spot the gorilla? For people who haven't seen or heard about a video like this before, about half missed the gorilla. If you knew about the gorilla, you probably saw it. But did you notice the curtain changing color or the player on the black team leaving the game? Let's rewind and watch it again. Here comes the gorilla, and there goes a player, and the curtain is changing from red to gold. When they're looking for a gorilla, you often miss other unexpected events. And that's the monkey business illusion.
That, my friends, is why you lose your keys. Now, because I'm a behavioral psychologist, I have to introduce some of the technical jargon, the technical vocabulary. So I'll share one more screen with you. This is the technical dysfunction of visual memory. It's also called palinophasia. It also hallucinatory palinophasia. And that's the way I learned how to pronounce the words. Now, in England or Europe, the vocabulary is pronounced a little bit different, but it doesn't matter. It is a phenomena of misperception in the brain. And we all suffer from it. Now, some people suffer from it more than other people. And I want to wrap up with a final, oh, I forgot this one, sorry. Your brain, my brain, everybody's brain is bad at doing everything, everywhere, all at once. It actually costs a lot to pay a little attention. Your brain, one more time, is bad at doing everything, everywhere, all at once. Multifunctioning is multi-mistaking. Try not to do it. And let me prepare a little bit. Now, I really, no, I was